Hello and welcome to Indis Tech. My name is Enoch, and in this video, we are going to be talking about how to create a computer-based test program using Python programming language. Had you ever taken a course or a test or an exam on online, e-based? That question system where you have options and you can tick for those tests can be created or can be written using Python. In this video, we are going to be looking on how we are going to be doing it. In the previous video, we had talked about lists and then we've talked about tuples. As we said, you could find them in the description below of this video. You could go to Indis Tech and see some of our resources and get to see how we do the things that we do. And in this video, we are going to continue on that note. So first of all, we'd assume that this is a freshman year test for a student in physics. So let's title our code physics test, for freshman year. So I think that could go for the test. So we would need to define our questions, and we'll be doing that in tuples with a tuple. And the difference between a tuple and a list is that tuples are represented with normal brackets, and for list are uses the square bracket, right? So, and also for a tuple is immutable. It means that you cannot change the items or the sequence in the tuple, whereas in the list, we did list manipulations. You could change or tweak the order or sequences of the items in a list. So we'll need questions as a tuple. We'll also need the options that we'll be having also as tuples, and again we would need the accurate answers for the questions that's to as tuples. So that being said, we would need to form the question, and because of I think I had the questions written somewhere, so we can just pick the questions and then just copy them here. So this question one. What is the unit of weight? Question two is what's the unit of luminous intensity? What's the unit of power? What's the unit of frequency? And which of this is not a scalar quantity? And you would find that each of them are in a quotation separated by commas. So these are the 5 questions, and your questions could be more than 5 or less than, depending on the test. And for the options also, I had it copied out, so let's get the options out, and then so for the options we have this as this. So you have the options is a two-dimensional tuple having this is the main tuple, this and this. Alright, so this is 3. So this is the main tuple, this from this bracket, covering from this bracket, and this bracket. In each of the tuple, you have another tuple consisting of the options for each questions. So this is the options for the first question, this is options for the second question, this is options for the third questions, and that goes on. So for the answers, the accurate answers, it should be C for the individual question. We have C, we have D. Alright, it should be D. Then we have it at B for the third question. We have it at D for the fourth question, and we have it at C for the last question. So this is, so to speak, that we need to define some variables also. For instance, when the candidate puts picks an option, let's create a list for that. By this, we are creating a list because we'll be having to store each of the individual attempts of the candidate into this particular list as trials. We'd also want to initialize his score or her score, the candidate score, to 0, and then we'll need another variable, let's call it question number, which will help us track what question that we are in for at any point in time in the code. So this basically would be the variables that would need for this to run. We'll create a for loop. We'll create a for loop for question in questions. Print question. So what this loop will do is that for each individual item in questions, because a question is a tuple of many items. So for each of it will print this. So let's try and run this and see. Just F5. Of course, we'd have to save it. So let's save it as physics test physics.py phy.py, and when we do that, we'll allow it to run. So you'd say it runs through all the questions in the question list. So we have question 1, we have question 1, we have question 2, we have question 3, and so on and so forth. So question 5. So that's basically what we've done. So we would need to impute the options. We need to impute the options for this. So in order to do that, we'll have another for loop. So for option in options, if we print this, print option, if we do that, we will not be able to call the items, because you see these two lists are different. This is a two-dimensional list, this is a two-dimensional tuple, while this is just a normal tuple. So if we are to run this, it will bring us an error, because it will not be able to call an individual tuple without having to call it. So let's try it and see what we're seeing. So we should have, you'd see what is going on here. So it's bringing for each individual, is bringing B. So it's bringing all of the tuple individually, and that's not what we want. That's bringing all of the options for all of the questions. So in order to get that corrected, we'd have to tag the question number that we are talking to, call the individual tuple for the, we'll have to call the individual tuple in the second tuple. So we have question number. Since it was initialized to 0, it will run like an index across the options. And when we do that, we'll see what we'll have. Yeah, so you notice it separated it for each of them. But again, you'll find out that this option is the first option for all of this. The reason why this is because question number is initialized at 0, and it will start counting this as the first item, and it's not incrementing. So in order to get that, we need to increment it so that it can run through the different options. And by that, would have to maybe call another put another would have to increment, you have to increment the question number by 1. So we do that by +1, and that will be that. But before then, we'd also want to be able to collect the items for, we want to collect the items for the candidate. So we can write let's have it as trial to be equal to the input function, input enter the, alright, let's use correct option, enter the correct option with A, B, C, or D, and that would have that the input statement. Now the candidate can return in lowercase, so to ensure that it returns an uppercase, we'll have to use it to ensure that the candidate, and whatever the candidate puts, let's put it in trial. So we have, okay, let's append it. Then the append function will append whatever he puts into this as trials. So we'll append this information here in. That being said, so, and we would want to write another statement and another conditional statement here to say that if trial, which would be the individual answer, is equal to so we would have to have answers if it's equal to the, remember we had put the answers, the correct answers for each question. So if that is equal to the answers in question number, that would be our iterator for the individual, that would be our iterator um for the individual answers in trial. So if that happens, we can increment score to +1. Yep, we can increment score to +1. So yeah, so it will increment the score +1. That if that happens, otherwise we can leave that at that, and yep. So that would be that. So yeah, if we should run this, we should be able to get, so we can have our results, so we can have, or we can have the score, the value of the score, we can have it as score is equal to score, because we want to present the score in percentage. So the score will be the length of the answers, the length of answers or trials, whichever. Yeah, let's use trial. That will be the options that he brought. So the length of trials multiplied by 1000, or multiplied by 100. That will give us the score value. We can, yeah. So, and then we can have the print statement. So we can have something like this. That is the results. Yep. And then we can also print your score is, we can use an f string so that so your score is, since it's an integer function, we can call an integer of score, and then in percent, we can call the percentage of score in percent, and then we have this, and I think we can close this. So that will be the score of the user. Let's run this code and see what sort it may look. So we have, this is the first question. This is the first question. All right, so let's say, let's choose B. It brings the second question. Let's choose C. Let's choose B. Let's choose D. And let's choose A without having. So we have 40.0%. So that's our score. He was able to collect that and he returned that in percent. Now we can still do a few things to this code to be able to show the user, because many times if you write code, they can even show you the scores, your answers for each question, and we can do that here. We can show the answers generally in another, as part of the output that comes out. So we can have your scores. Your scores are, alright, your scores are, I can end it with an end statement. Your scores are for, I can print the scores. So for trials, where we have, okay, well, for trials, trials, we have print uh, let me separate this by a space, comma, so to speak. Yeah, so this could be the, if I run this code too, and I can also have another, I can now say print um I can have this to print the accurate answers for the accurate answers apart from his scores. So we have for alright, so for us to be able to create space, I can have another print function um, of this. We'll have this here. Yep. Just to make a sort of separation. Yeah. So it will now be the correct scores. Then it will now be for answer in answers. Would have to print answer. Maybe sort of a thank you for taking the test. So we can have this as part of our code to give. So let's kill this and rerun it again to see what goes on. What is the unit of weight? Let's say joules, which is wrong, but okay. What's the unit of luminous intensity? Candela, correct. What's the unit of power? It should be hertz, but that's wrong. But let's still go on. What's the frequencies measures in hertz? And what's this? What's which of the following? Which of these is not a scalar quantity? So we have c velocity is not a scalar quantity. So it runs. So he said my score is 60%. Your score is a. Or this got me this. So let's take this out and all right. If I should do this to this so that it will all come out on the same plane, so then our output will look good. Let's rerun this again. This time around we're going to get all of the answers correctly so that we ensure that our code runs perfectly. So weight is measured in kilograms, luminous intensity is candela, power is in joules, frequency is in hertz, c is not a velocity, is not a scalar quantity. So I have 100%. These are my scores and these are the correct scores. Thank you for taking the test. So with this we are able to create a CBT, a computer-based test, and that works for it. So thank you so much and see you next time.